Okay, so when we want to solve a system of when we want to solve an equation that has a missing number, we have to kind of think about how our families of facts work. Especially, well, first of all, we'll start with addition and subtraction. So when we have a family of facts, we're talking about three numbers that we can write two addition and two subtraction sentences for. So, for example, say we have this family of facts: 2 plus 3 equals 5. You can also write it 3 plus 2 equals 5. You can write 5 minus 3 equals 2, and you can write 5 minus 2 equals 3. This is called a family of facts, okay? And you can look at each situation and kind of try to figure out what would you do if one of those three numbers in the equation was missing. So like in the first equation, if you had 2 plus d equals 5, and you're trying to figure out what number goes here, well, how could you figure out it? You know it's 3, all right? You know that when you have an addition sentence in a family of facts, the two smaller numbers are on the left side of the equal sign. They're being added together to make one bigger number, which is on the right side of the equal sign. Okay, so you know that if you're adding 2 plus something to get 5, whatever that thing is going to be smaller than 5. And so how do you find out what it is? Well, if you look over here at the three numbers, think about it. You know that D is going to be 3. How do you get 3 if you've got 5 and 2? You would say 5 minus 2 equals 3. So you would take this number, that's the biggest number, the one on the right side of the equal sign, and you would subtract one of the smaller numbers, the one you have, 2, and that would tell you that D is 3. All right, so even if you have a more difficult problem, you would know that, all right, if I've got something plus a missing number and it equals another number, then to find the missing number, all I need to do is take the big number from the right side of the equation and subtract the smaller number from the left side. All right, if you have a subtraction problem like this, 5 minus 2 equals 3, say you had 5 minus d equals 3. Well, how are you going to find out what that number is, that d? You know it's 2 because you know this situation. All right, but if you just had the 5 and the 3, what would you do to get 2? Well, you would take the 5 and subtract 3, and that would give you 2, which would be the answer. All right, so in that situation, if you have the biggest number in a subtraction problem, you're going to have the biggest number coming first, and then you take away one of the smaller numbers and get the other smaller number. So when you can't remember what you should do, just write an easier equation and figure out what you would do if one of those numbers was missing, and then just do that. All right, so if I have this problem here, 12 minus d equals 1.43, and I'm wondering, well, I have no idea, who knows what that thing is? Well, think about it. If you had an equation like 12 minus 4 equals 8, all right, you know that's an easy equation. You know how to do that. What if it was 12 minus d equals 8? Well, you know d is 4 because you just wrote that equation. But how could you figure out what d was if you didn't know? How could you get 4 if you have the 12 and you have the 8? You subtract 12 minus 8, and that'll give you the 4. So you take the first number, the big number, that's before the subtraction sign, and you subtract the number on the right side of the equal sign, and that's going to give you the missing number. 12 minus 8 is 4, so 12 minus 8 is this. So I can do the same exact strategy in this problem, even though the numbers are different. They're all in the same place. I can take the first number, the biggest one, and I can subtract the number on the right side of the equal sign to get my missing number. So 12 minus 1.43, and I'll have to write that this way, 12.00 minus 1.43. And then to subtract here, I'm going to have to borrow because I can't take 3 away from 0, but I can't borrow from 0 because there's nothing there. So I have to go all the way over to the 2 and borrow 1, and so there's 1 left, and that makes this 0 a 10, and now I can borrow from that 10 to get something to take the 3 away from. So remove the 10, make it a 9, make this a 10. 10 minus 3 is 7. 9 minus 4 is 5. Put your decimal where it belongs, And then you've got 11 minus 1 is 10. So D is 10.57, I think. Well, let's make sure it really is 10.57 by checking it in the problem. Put this number where the D is and see if it actually works. So 12, and I'll say 12.00 minus D, which we just said is 10.57. Let's make sure we get 1.43 for that. So borrow from this, make that a 10, then borrow from that, make that a 10. 10 minus 7 is 3, 9 minus 5 is 4, bring down your decimal, 11 minus 10 is 1. So it works. All right, so this is the answer. This is the missing number. All right, so whenever you have a problem that is difficult, make an easier problem so that you can figure out what to do. All right, so this is number 6 from lesson 44. So now we have the missing number coming first, and we don't know what to do to get that. Well, remember that when you write a subtraction problem like 5 minus 2 equals 3, remember that the biggest number of the three numbers you have there is first. You're taking something away from the biggest number, taking a smaller number away, and you get another smaller number. All right, so if the 5 was not there, if I didn't know what it was, pretend that it's missing, how would I get a 5 if I just had those two numbers? I would add them. 3 plus 2 would give me that 5 that's missing. So if I could add the 3 and the 2, 3 plus 2 equals 5, to get the 5 that belongs there, then I can do the same thing with this problem, even though it's more complicated. All I need to do is add 1 and 3/5 plus 6 and 4/5. Just do what you would do in the easier problem. If the first number's missing, add the other two together in a subtraction problem, okay? This works in a subtraction problem. The biggest number comes first. So to get the biggest number that's missing, you add the two smaller numbers. So 3/5 plus 4/5 is 7/5, and 1 plus 6 is 7. So I've got 7 and 7/5. 7/5, I need to exchange one whole and give it over to the ones place. So 7/5 is 5/5 and 2 more fifths. 5/5 is 1. So I've got a 1 that I can add to the 7. That gives me 8, and then 2/5 left over. Okay, so that was 7, and then 5/5, and then 2 more fifths total. All that together. That gives me 8 and 2/5. All right, now you've got another problem like the one we did at the beginning, where you had the missing number coming second in the subtraction problem. So you do the same thing. First of all, you can go ahead and change the square root of 36 to 6, because the square root of 36 means what number do you multiply by itself to get 36, and that is 6, because 6 times 6 is 36, which means the square root of 36 is 6. So 6 minus m equals 2 3/10. Now again, if I don't know what to do, just write out a simple subtraction problem to help me figure it out. 5 minus 4 equals 1. All right, that's a simple subtraction problem that I know all the numbers for. Suppose the 4 wasn't there, and I was trying to figure out what it was. How could I figure it out? Well, if I want a 4, I can take 5 and subtract 1, and that would give me my 4. 5 minus 1 is 4. That's the missing number. So I'm going to do the same thing here. I'm going to take the number that's here, which is where the 5 was, and I'm going to subtract the number that was on the right of the equal sign, 2 3/10. All right, so I'm going to do this subtraction, and that will give me the missing number, 6 minus 2 3/10. All right, so to do this problem, I'm going to have to change that 6 to 5 and 10/10. All right, so I borrowed a whole from the 6 so that I'll have something to take that 3/10 away from, because I need a fraction there to take it away from. So I borrowed one whole, which is 10/10. So 10/10 minus 3/10 is 7/10, and 5 minus 2 is 3. So that is m. And if I want to check it, all I have to do is put in 3 7/10 where that m is. So 6 minus 3 7/10. Let's see if it actually does come out to be 2 3/10. Again, I have to borrow a whole to get 10/10 here. So I'll have something to take that 7/10 away from. 10/10 minus 7/10 is 3/10, and 5 minus 3 is 2. So yeah, that does give me 2 and 3/10. So this is correct. M really is 3 and 7/10. All right, here's another situation. This time we have an addition problem where we're trying to figure out the missing number. So how do addition problems work? Well, let's see. 2 plus 4 equals 6. I write a simple addition problem. Now, if I didn't have that 2, if the first number in this equation was missing, and I didn't know what it was, and all I had was the 6 and the 4, how would I get that 2? Well, 6 minus 4. I would take this number and I would subtract that number. So that's what I'm going to do in this problem. I'm going to take the big number 9 and I'm going to subtract the 3 and 5/8. And that will give me the number that should come first. So I borrow again from the whole number and I'll put 8/8 here so that I can take away 5/8. 8/8 minus 5/8 is 3/8. And 8 minus 3 is 5. All right, so x is 5 and 3/8. Let's check to make sure that really is true. Let's put this number in for x and see if we get 9. So 5 and 3/8 plus 3 and 5/8 should equal 9. 3/8 plus 5/8 is 8/8. 5 plus 3 is 8. 8 and 8/8 is 8 plus 1, which is 9. So yeah, this works. This is what x is.